Hi, my name is Kareem Helmi, and I am going to be presenting for the Cascade Broadcasting Group. Our system is broken up into question generation and question answering sections. The first, the question generation component, accepts as an input a raw text file. It then, on a sentence-by-sentence basis, proceeds to rearrange the sentences so that the prepositional phrases are terminal. It then manipulates the parse tree of the sentence and transforms it into a question depending on its type. As a preliminary example, if our input text is "Bob would like an apple," it'll convert it into the following tree. This will lead us to the output, "What would Bob like?" the answer to which is an apple. As a secondary example, if the input text is "The apple is green," it'll convert it into this tree. It'll then use WordNet to find the hypernym of green, which is chromatic color. This is a useful trick because otherwise we would be stuck asking a question like, "What is the apple?" which is incredibly ambiguous and overall not a good question. Instead, we get the much more specific, better question of, "What chromatic color is the apple?" Our tertiary example shows the prepositional phrase rearrangement. So if our input text is "On April 1st, Google launched Google Knows," it'll rearrange the original tree into the following tree. It'll then check the membership of "in." Now, NER tagging marks April 1st as a time or date, which yields a when question. But if it were, for example, a location, it would yield a where question. Our output in this case is, "When did Google launch Google Knows?" Our question answering system, in contrast with the question generation system, is relatively naive, which is actually a perk given the small sample size of one text document that we're given. It uses a TF-IDF classifier to compare the question to each sentence from the input article. However, this bag of words model is modified because it incorporates semantic relations between words in order to disambiguate. So if a word is not exactly like one that is found in the document, it's not a big deal. It'll be able to deobfuscate questions, which even outside of competition is useful because if, for example, we're using search terms, it'll be able to find the results despite imprecise search terms. It'll then return the sentence with relevant information. For example, if our question is, "What is located at the junction of the Allegheny, Monongahela, and Ohio rivers?" it'll use semantic matching to replace the word junction with confluence. This will give us the question modified, which is, "What is located at the confluence of the Allegheny, Monongahela, and Ohio rivers?" Then be able to search the source document. Junction doesn't appear in the source document, but confluence does. So we'll find that located at the confluence of the Allegheny, Monongahela, and Ohio rivers is Pittsburgh. As an example of question answering, if we have our input text, "On April 1st, Google launched Google Knows." Google Knows was a parody, and Google is known for making jokes. Our input question is, "When did Google introduce Google Knows?" We'll use TF-IDF to find the best match in the text. So semantic matching will recognize the similarity between launch and introduce. Without semantic matching, this wouldn't be possible, and we might, refer to the second sentence instead of the first, because they both contain Google Knows. With semantic matching, though, we're able to find that the first question is the one that we want, and we'll return, "On April 1st, Google launched Google Knows," which is the correct answer to the question. The tools we used were Stanford Core NLP, Stanford NER, WordNet, NLTK, and the Python bindings for all of the above, because all of our code was written in Python. This turned out to be really great because Python allowed for rapid prototyping and had bindings for most of the NLP libraries. It did have its issues in that many NLP tasks are computationally expensive, and Python isn't exactly the fastest language, but despite that, we think we made the right choice. Dependency parsing and information extracting especially are pretty expensive, and approximate solutions are faster and work greater with enough data, but turns out that one file might not be enough for that. So with our system, we can infer the answers based on question types and tags, and we find that not exactly all statements are convertible to questions because of ambiguity or other issues with the sentence. So anyway, thank you very much for watching our presentation, and we hope you enjoyed it.